video on 5.1, the absolute value function. The absolute value function is, we teach this a little bit later because it's extremely similar to another function that we have already studied. So we're going to start by just thinking about what is an absolute value and what do they do. So an absolute value are those straight up and down bars that you've seen it a few times in our notation. What an absolute value does is it it measures the distance that something is from zero. So for example, here's my number line. If I put the number 2 on the number line and I put the number -2 on the number line, how far away are these values from 0? Well, 2 is a distance of 2 units away, but -2 is also a distance of 2 units away. When we're measuring distance, we would never say it is -2 feet or it is -5 miles to grandma's house, right? We always say distance is a positive number. So absolute values are measuring distance, and in essence, they're turning every value that are inside of them positive. Even if I were to have something like this, -1 plus 5, the absolute value of it, what I would do first, they're kind of like parentheses, right? So I would figure out what is -1 plus 5. Well, that's 4. And then that would give me the absolute value of 4 is 4. Vice versa, if I were to have 1 minus 5 with the absolute value, I would treat it like parentheses. So I would get -4 absolute value, which is still +4. So no matter what number we end up with on the inside of absolute values, it's always going to give us a positive because it's measuring the distance from 0. We're going to use that to start graphing what these look like and also writing some things in our notes. So an absolute value function is not super tricky. We can stick with our pretty usual table values, -2, -1, 0, 1, and 2. And the way we get our y values, which I should write this down here, is we are going to plug in those numbers into the function. So we're taking absolute values of all these numbers. If you remember what we just mentioned, absolute values turn everything positive. So the absolute value of -2 is +2, -1 is +1, 0, 1, and 2. When we plot these points, we get a perfect looking V-shaped graph. My computer automatically wiggles this. I don't know why. It should be straight lines. So it looks extremely similar to a parabola, but a parabola would curve, right? It wouldn't go up at a perfect slope. So our slope here is going up 1 over 1, up 1 over 1, up 1 over 1, versus a parabola doesn't go up at the same amount every single time. So, but it looks like almost exactly the same. Now, the V-shaped graph has an axis of symmetry, just like we had in a parabola, and that axis of symmetry is going to be x equals 0 until we start moving it around, but it's always going to be the same as the x value of the vertex. So these will always match each other. Now, of course, to keep life interesting, we are going to pause really quickly. Okay, we're back. Sorry, I was interrupted. So in the second box, we're going to talk about the translations, which, oops, I'm just going to flip the screen so you can see it. They're the same as the translations we've been talking about all semester long. So the inside number, inside the absolute values, is going to move your graph left or right, opposite of what you would normally think. And the outside number is going to move your graph up or down, the same. The axis of symmetry is always the same as the x value of your vertex, which is the opposite of the inside number. So this, again, it is very, very similar to when we were graphing parabolas. If you need to pause this video to take some notes, please do so. Otherwise, we're going to move on to the next piece. Some things to remember when you are graphing absolute value functions is that taking the absolute value of a number always makes the number positive. Okay, so if you want to write an example, the absolute value of -4 is 4, and the absolute value of 4 is 4. It turns it positive no matter what, does not switch the sign. The graph of every absolute value function should make a V-shaped graph. So it's always, and it generally starts at 0, 0, but then we will move it around based on the translations. And the H switches signs between the equation and the vertex slash the axis of symmetry. So what we mean by that is if I had x plus 2 minus 3, my vertex would be a -2, -3, opposite of that inside number. Okay, so an example here is if I had the function f of x equals the absolute value of x minus 5 minus 7. Very similar to what we were just doing, we're going to write the translation. So what does that -5 do to the graph? It moves it right 5. And what does this -7 do to the graph? It moves it down 7. Doing it in the reverse, we can actually know a translation and write the equation. If I said that a function has been translated 5 units to the left and 11 units up, well, I would want the absolute values with the x on the inside. 5 units to the left would mean it's actually going in a negative direction, so I would need this to be a positive 5. And if it's going 11 units up, that means I need a plus 11 on the outside. This is in page 10 in the back of your packet. We'll just do a couple more examples and then that will be it. The first one says, write the absolute value equation of a graph that is translated 3 units left and 6 units up. If you want to pause the video, turn to this page in the back and try that one. That would be great. And then we can check your answer when you are done. Hopefully you got the answer x plus 3 and plus 6. The plus 3 is that 3 left, and the plus 6 is that 6 up. Okay, and the next one, it says write the absolute value equation for something that's been translated 11 units right and 5 units down. Pause the video, see if you can try this one on your own, and check your answer when you are done. Did you get x minus 11 and plus, oops, sorry, minus 5? This is that right 11, and this is down 5. Notice I'm including the absolute value bars every single time, and we're just putting numbers inside and outside. All right, the last one, it says, given the absolute value graph below, identify the translation, the vertex, the axis of symmetry, and then write the equation. So one of the things you do need to remember, just like in a parabola, is that our regular absolute value function starts at 0, 0. We are going to then count how far it moved to get to that new location by looking at the vertex. This had to move left 3 and down 4. So the coordinates of that vertex would be -3, -4. Our axis of symmetry, that line that goes down the middle of the graph, is always the same as our x value, x equals -3. And so the equation of this, using the same logic we used in the last problems, would be x plus 3 minus 4. All right, that is it for absolute value functions. Easy peasy, hopefully. You're going to work on the 5-1 worksheet as well as the 10-1, 10-2 worksheet today. I hope everything goes well and you have a great day.